Okay, so the first definition we're going to look at today is the definition of bisect. A lot of these definitions we've already learned, but I just wanted to refresh you on them before we started. So definition of bisect is to divide into two congruent parts. Now, this could be sides, so we could have sides that are congruent, or what else can be bisected? Angles. So we'll have to look and see if it's talking about sides or angles that are being bisected, okay? And the appropriate abbreviation, because I will let you abbreviate when we're doing proofs, is definition of bisect, okay? Now, definition of midpoint is the point that divides a segment into two congruent parts. So if it's a segment, that means it can only be a side. And so the midpoint is going to be in the very center of that and split it into two congruent parts. Okay. Now, the definition of perpendicular and right angles is a line intersecting to form 90-degree angles. It is often written by this sign, and you'll see this in our pictures. The upside down T means that it is 90 degrees. So if I was to draw a triangle, and it told me there was a line perpendicular, that means it would come straight down and form 90 degrees. Now, do not get this confused with a perpendicular bisector. Nowhere does it tell me it bisects. This only means that it forms 90 degrees. Okay, so this has to do with angles and not sides. Now, it's been a while since we talked about vertical angles, okay? So we know that vertical angles are always congruent. So vertical angles are opposite of each other. So I'm going to draw some vertical angles. So when two lines intersect, it causes vertical angles. So that lets me know that this angle and this angle is equal because they're vertical angles, but also this angle and this angle is equal. Okay, are there any questions about those? Okay. It's also been a while since we've talked about alternate interior angles. Okay, what do we need in order to have alternate interior angles? Two parallel lines. So I'm going to draw two parallel lines that is being cut by a transversal. So if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So do y'all remember how to label that these lines are parallel? You do the arrows. So I'd put an arrow on this line and an arrow on this line to let me know that they're parallel. Then I'm going to go ahead and circle this because this is my transversal. Okay? Now, my alternate interior angles will be located inside the parallel lines on opposite sides. So this angle and this angle would be one pair. And then this angle and this angle would be the other pair. Do y'all remember that? Okay. The next definition we're going to look at is the isosceles triangle theorem. So the isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite of them are congruent. So I'm going to draw the picture to show you this. So I'm going to draw an isosceles triangle. So in an isosceles triangle, the two legs are congruent, right? then this theorem tells me that if these two legs are congruent, then that means, that implies that the angle is opposite, so this angle and this angle would also be congruent. So I can go ahead and put angle marks right here to show that this and this is congruent. Okay? So the fact that these sides are congruent shows me that the angles are congruent. Now, the converse of that would be it backwards. So instead of doing sides to angles, we would go what? Angles to sides. So this time I would have a triangle, and what two things would be congruent? The angles. And by these angles being congruent, I would be able to imply that the sides across from them, this side, and the side across from this angle, these two sides would be congruent. And the way that I keep that separated or not getting confused which one's which is, if you read isosceles triangle, what is it talking about? What does isosceles triangle mean? A triangle with two congruent sides. So to use isosceles triangle theorem, you first have to have two congruent sides. Then you apply something about the angle. Whereas the converse, you don't have to worry about the sides. We're looking at the angles, and it implies the sides. Okay? Do we have questions about those two? Okay. Now, this is what we've just been going over the past couple days. So we're just going to draw in some pictures. So for side, 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 we'd have two triangles with all the sides, all the corresponding sides would be congruent. So this side and this side would be congruent. This side and this side would be congruent. And this side and this side would be congruent. Okay? Then for side, angle, side, where does the angle have to be in order for it to be side, angle, side? In the middle of what? Both sides. Very good. So when you draw your picture, whatever two sides you make congruent, the angle has to be between them. So if I did this side is congruent to this side, and this side is congruent to this side, then the angle would have to be the one that is between these two sides, which would be this angle and this angle. So we'd have side, angle, side here, and side, angle, side here. Okay, and then the flip of that is angle, side, angle. So where is this side going to have to be in reference to the angles? In between the angles. So when you draw your pictures and you make two of the angles congruent, the side that connects those two angles is going to have to be the side that's congruent. So let's say we did this angle and this angle was congruent. And then this angle and this angle was congruent. Then the side that connects those two would be this side. Okay, questions so far? Okay, and then angle, angle, side. Yes, ma'am. On which one are you asking about? ASA. What do you mean, can it switch to the other side? Yes, it could be on the other side. Okay. Now angle, angle, side. So our two angles have to come, our two angles that are congruent have to come before the side. Could we do side, angle, angle? Yeah. It can be angle, angle, side, or it could be side, angle, angle. Because technically, it's still in the same order. It's just whether you start with the angle or you start with the side. So if we did that, we'd have an angle, and then an angle here, and an angle here. What would be the next side after that blue angle? The one on the what? The one on the right. So we could say angle, angle, side, or if you happen to start with the side, you could do side, angle, angle. Either one of those works. Just remember, you cannot skip a whole angle and a side together. You can skip a side, or you can skip an angle, but not a side and an angle. Okay? And then reflexive property is what I just showed you when we did HL. Reflexive property, and some people remember this by thinking of it as reflective. If you look in the mirror, what do you see? Yourself. The exact same thing. So in reflexive property, it tells us that whatever it is congruent to itself. So in the example we saw earlier, it was a triangle. There was one big triangle that was split down the middle by a line. And so this line is reflexive to itself because whether I'm looking at the left-hand side of the line or I'm looking at the right-hand side of the line, it's going to be the same length. So the way that I would do that is I'd put tick marks to let it know or let me know that this is congruent to itself. Okay, so we're good on definitions? All right, let's look at our marking pictures, or marking pictures for proofs now. So keep that definition sheet out because we're going to be using it as we mark pictures. So looking at number 1, we have that BD bisects AC. So that means BD is cutting AC in what? In what? In half. So what two things are equal then? AD and DC. So that's going to be the first thing that we want to write down. We know that AD is congruent to DC by definition of bisect. So I'm writing everything that I know is congruent, okay? Now, there's also something that is implied by the picture. It's not labeled, but I can see that there is something there. Does anybody notice anything else that may be congruent in the picture that is not labeled? Okay, we do not know anything about that because it doesn't say that we're bisecting angles. It only says that we are bisecting the side. So what I can see, and it takes a little practice to see this, BD. Isn't BD a side in this triangle and it's also a side in this triangle? So that means that it is reflexive, okay? So I know that BD is congruent, and I like to write it the opposite way and say is congruent to DB because it doesn't matter if I start at the top and go down or start at the bottom and go up, that's the same length. And this is because of reflexive property. Okay, and now if I looked at this triangle, ABD, I have a side, an angle, and a side. Do I have the same side, angle, and side in my second triangle? I don't? I do? So then what theorem or postulate can I use to prove these are congruent? Side angle side. Okay, let's try another one like that. So looking at number 2, it tells me that N is the midpoint of LP. So what is the definition of midpoint? It divides a segment into 2 congruent parts. So that means NP and LN would be congruent. So that's what I'm going to write down. LN is congruent to NP, and I know that because of definition of midpoint. Okay. Now, there is something implied by the picture that is not labeled. What do you think? Yes, those are congruent, but that's labeled, so we don't actually have to write that down because it's given to us. So we're looking at something that's not labeled. What do you think? Very good. So this side is shared in both triangles, which means it's reflexive. So I know that MN is congruent to NM by the reflexive property. Now, is there a theorem that can prove these congruent? Looking in this one, we have a side, and an angle. Is SSA, does that work? No. So this is SSA, which means it's not congruent. Okay, how are y'all feeling about this? Okay, let's try some more. Let's look at number 3. So in number 3, we already have that these sides are congruent. It tells me that SV and VS are congruent. So SV and VS, what is that called? Reflexive property. So I'm going to go ahead and label those are congruent. Okay, now, if I have that these sides are congruent, what type of triangle does that mean that is? Isosceles. And what can I use if it's an isosceles triangle? Isosceles triangle theorem. So what does that tell me? The 2 angles opposite are congruent. So the angle opposite here would be R. The angle opposite here would be T. So that means T and R are congruent. So we'll write angle T is congruent to angle R. And how do we know that? Isosceles triangle theorem. Okay, and that is all that I can find. Reflexive property, there's nothing else that I see in there. So I have an angle, a side, and a side. Is that going to work? No. So this we could not prove was congruent. Okay, let's try number 2. So in number 2, it gives you that this side and this side is the same. Sorry, number 5, this side and this side is the same. And then it tells me that angle 1 is congruent to angle 2, so I'm going to go ahead and label that these are congruent. Now, there is something in the picture that is not labeled, but is congruent. Very good. Okay, we have vertical angles right here. So this angle and this angle is congruent. So I'm going to put congruent, and I'm going to put VAT here. Since we don't have these numbered or lettered, you can't really write what angle is congruent to what, but we'll just put VAT. Now, is there anything else that we can imply about this? Nope. Nope. In order to have that, what would we need? A transversal, but we'd also need two parallel lines. Okay? So this is all that we can see. So I have an angle, a side, and an angle in this triangle. I have that same angle, side, angle in this triangle. So what theorem could we use to prove this? Angle, side, angle. Okay? Questions? Okay, I'll do a couple more for you. So let's take a look at 7. So in number 7, it tells you that these angles are congruent. You're given that. And then you're given that these sides are congruent. Now, up at the top, it tells me that WH bisects angle IWT. So we're looking at an angle right here that's being split in half. So IWT is this whole angle up here. So it means this angle and this angle are congruent. Okay. Is there anything, since I'm not told anything else up here, is there anything implied by the picture? You can look at the picture and see that there's something not labeled, but that is congruent. And there's only 2 options for that. It's either vertical angles or it's reflexive property. And so almost everyone will have one of those 2. So this one, yes, is reflexive property. So this is equal to itself. So we would write WH is congruent to HW, and that's by reflexive property. Then I also want to go ahead, we didn't write down this information. Where WH bisects IWT, that makes angle IWH congruent to angle TWH. And what definition is that using? Definition of, what does it say up here? Bisects. Okay, I have 2 more unless you think we can just live on 1. Okay, well, I will do 2, and those of you who only need 1 can go ahead and work. Okay, so number 8 says XY is parallel to WZ. Okay, so how do we label that something's parallel? The arrows. So I'm going to put arrows here to let me know that these are parallel. And then y'all have labeled that this angle and this angle is congruent to this angle. Okay, so looking at the picture, because this is all that we're given, is there something that's implied that is not labeled? What do you think? Vertical angles. So this angle is congruent to this angle. So I'm going to put angle and this angle right here. I can't label it V because both of these could be V, This one would have to be WVX. Could it be XVW? Oh, thank you. It would be YVX. The other one will be? So YVX is congruent to WVZ. Okay? And we know that because of vertical angle theorem. Okay, technically, I want to talk about why X and Z are congruent. So if these are parallel lines, if X, Y, and WZ is parallel, what does that make this right here? The transversal. So what type of angles are X and Z? Alternate interior. So I'm going to write angle X is congruent to angle Z because of alternate interior angle theorem, because you may have to identify that at some point, which means that Y and W are also what? They're congruent because they're alternate interior angles. Okay, we forgot to, in 7, and we'll come back to 8. In 7, we forgot to write down the theorem that works. So if we're looking at the theorem that works for 7, like side, 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 angle, side, what would work here? Okay, we have a side, angle, side. Is there another way you could do it? You could do angle, side, angle. Good. Okay. Now, what about in number 8? Is there a theorem that proves these two triangles congruent? Why not? So if we have AAA or angle, 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 that means it's not congruent. Okay, if you get this, go ahead and work ahead. I'm going to do number 9, and then I'm going to let the rest of you work. You list everything, yes. What you want to do is list everything that's congruent, why it's congruent, and then tell me the theorem that makes them congruent, if there is one. So in number 9, it tells me that these two are congruent. Then it tells me A is the midpoint of PT. So if this is the midpoint, by midpoint definition, it means that this segment and this segment is congruent. So PA is congruent to AT, and that is by definition of midpoint. It also tells me angle PRA is congruent to angle TRA. So PRA is this angle right here. TRA is this angle right here. And there's actually two things that are implied here. I have that these sides are congruent, which means that it's an isosceles triangle. So the angles across from them will be congruent. So P is congruent to T, so I'm going to write that down. Angle P is congruent to angle T, and that's by isosceles triangle theorem. And then the last thing that's implied is the fact that RA is shared in both triangles. So this is congruent to itself by reflexive property. So RA is congruent to AR by the reflexive property. So then when I'm looking for a theorem for this one, I have that all three sides are the same in both of them. So I could use side, side, side. I also have side, angle, side. And then angle, side, side does not work, so we can't use that one. I do have angle. Oh, yes, we do have angle, side, angle. So any one of those would work there. So sometimes you can get multiple, and that's what I want to see. I want to see everything that you know.